We would like to tell about our work. We do the model of earthquake damage. And let's start from a description of the problem. In April of 2015, the 7.8 magnitude Gorkha earthquake occurred near the Gorkha district of Ganki Pradesh, Nepal. Almost 9,000 lives were lost. Millions of people were instantly made homeless and 10 billion in damages. About half of Nepal's nominal GDP were incurred. In years since, the Nepalese government has worked intensely to help rebuild the affected district's infrastructure. Throughout this process, the National Planning Commission, along with the Kathmandu Living Clubs and the Central Bureau of Statistics, has generated one of the largest post-disaster datasets ever collected, containing valuable information on earthquake impacts, household conditions, and social-economic demographic statistics. Our goal is to predict the level of damage a building suffered as a result of the 2015 earthquake. The data comes from the 2015 Nepal Earthquake Open Data Portal and mainly consists of information on the building's structure and their legal ownership. Each row in the dataset represents a specific building in the region what was hit by Gorkha earthquake. Let's start from data loading. We load the data from train value SysTV and train label SysTV.
Next, we performed some dataset preparing. So we picked out our numerical and categorical features, applied hot encoder and created new columns and dropped some encoded columns. So yeah, here's our encoding. Next, we provided some data analysis. So at first we checked out the number of nonce values in our data set. As you can see, there is 0 nonce. Next, we displayed the distribution of ages of the houses. As you can see, the most of them are below the 60 years old. Also, we displayed the correlation between main features. As you can see, damage grade doesn't correlate significantly with something. So as there is no obvious dependencies, we decide to leave features as they are and do not create any new.
After that, we create models. We start from the splitting. We split the set to our data to train and test sets, and we import the random forest classifier. Also, we search for the hyperparameters using grid search, and after that we apply the grid search with cross-validation. You can see that the ranges for the max depth, max futures, random state, and estimators was little, but it was thus about 44.4 minutes for searching the best hyperparameter. After that, we build the random forest model with using random forest classifier. You can see that the accuracy score is 0.73. After that, we build a model with using a XGB classifier. Do the same steps, do the grid search, and the grid search with cross-validation, and it was us 30 minutes. And after that, we create the model using XGB classifier, and the accuracy score for this model is 0.74. Results. Also, you can see the predictions. We predict the damage grade for our as you see, this plots number of buildings with each damage grade in prediction and the number of buildings with each damage grade in trend set. It's our prediction, it's our trend set. And you can see that F1 score for random forest is less than for XG boost. And it gives us the reason to say that XG boost is more efficient than a random forest. Here you see that F1 score for the best F1 score is 0.75, and it gives us reason to say that our model is good enough, and it gives us the opportunity to make the prediction with suitable accuracy. And I would like to add that when we're using scaling for non-features, it gives us a loss of accuracy about 0.5%. Thank you.